Today we're going to continue our study of Chapter 1 with Lesson 3. So Lesson 3 is Scientific Models. You will need your directed reading 1.3, which is in your EN. Our objectives today, you should be able to give examples of 3 types of models, identify the benefits and limitations of the models, and compare the ways that scientists use hypotheses, theories, and laws. And again, all videos will be attached to the lesson. So there are different types of scientific models. One would be physical models. And this would be things like the miniature volcanoes, that everyone wants to do for the science fair project, and steam engines. I mean, they actually look like the thing that they model. Mathematical models. This can be made up of numbers, equations, and other forms of data. Charts and examples would be examples of mathematical models that you will be doing with Mr. Weekly this year. And then there are conceptual models. These are probably the hardest to understand because a concept is kind of like an idea. So conceptual models are systems of ideas or comparisons of unfamiliar things with familiar things. That way it helps explain those things that are unfamiliar to us. Because when we're learning, we try to connect it to something that we already know. An example of a mathematical model would be a Punnett square. This helps scientists study the passing of traits from parents to offspring. And I believe you study this in 9th grade biology. So it's really, really interesting to study, and you can get really deep with it. But again, you'll learn more about that in 9th grade. So this section is building scientific knowledge using scientific models. There are things called scientific theories, and there are things called scientific laws. A theory is an explanation that ties together many related observations, facts, and tested hypotheses. These are called theories. So yes, you have a lot of study about them. Yes, you have a lot of data that's been collected and connected together to make it make sense. But a theory has not been proven 100% true. For example, there is the evolutionary theory. And many people, such as Bill Nye, that you're going to watch a lot of this year, he thoroughly believes in the evolutionary theory. Now, to a lot of people, that theory is just simply what it says. It is a theory. There's some evidence out there, but there's not enough. It's kind of like connecting the links in a chain link fence. For some people, in a theory, there are a few of those links missing. So that leads us to scientific laws. A scientific law is a statement of what will happen in a specific situation. A law tells you how things work. So the law of gravity. If you go anywhere on this earth and you let go of a pin, as long as you're on earth, it's going to fall to the ground. Now, why is that? It's because gravity is pulling it down to the ground. So gravity is a proven law. It's no longer a theory. Every now and then, things in science change. So if you have new evidence that challenges an accepted idea, that leads scientists to back up and re-examine the old evidence and reevaluate that old idea. And there are things constantly changing in science. So that is a very short lesson today. Our next lesson will be Lesson 4 on Science and Engineering.